Have you ever wished if this time could slow down a little bit? Well, guess what? You can, using Einstein's special theory of relativity, based on very simple two postulates. First, all laws of physics are same no matter seen from a stationary point of view or a point of view moving with a constant velocity.
It means that you can't really differentiate if you are moving at 100 km per hour or you're stationary until there is something to take a reference with.
Second postulate states that the vacuum speed of light is constant no matter seen from a stationary or a constant velocity point of view.
It means a person moving at 10 billion meters per second or a person perfectly stationary would see the speed of light to be the same 30 billion meters per second.
Pretty easy, you know? But these very simple postulates give rise to some of the most fascinating phenomena,
Such as time dilation, length contraction, mass variation, and my favorite, twin paradox. Now imagine a light beam clock consisting of a light beam oscillating between two reflectors L distance apart. The time period of one oscillation of this clock would be t. Now consider this clock moving with a velocity v. This time light beam has to travel an extra distance to complete one oscillation. Since the velocity of light is constant, so the time period of one oscillation would increase by a factor of gamma, where gamma is 1 by under root 1 minus v square by c square. Thus a moving clock runs slow, and so does everything else including your age. You just dilated the time.
because time is but a stubborn illusion.
Now imagine twin brothers Albert and Neil. Albert decides to go on a round trip to a distant planet on his spaceship that moves with a constant velocity, while Neil observes his brother on the spaceship. He sees that his clock is running slow, and so he is aging less. But here lies the problem. From Albert's point of view, it's the Neil who is moving away along with planet Earth, while he is stationary. So according to him, Neil is the one that aged less.
Oh god, these two guys never agree. Well, the solution lies in the problem.
When Albert turns around, he actually experiences centrifugal acceleration, but Neil didn't, and in an accelerating point of view, velocity of light actually slows down, and so does the time. It is at this point both agree that it's Albert who aged less and not Neil.
Fine. But here lies the quirk.
This solution to the paradox is only applicable in an unsymmetric situation like this. In case of a perfectly symmetric situation, there is actually no way to tell which body accelerated. So in such cases, the paradox remains unsolved.
So now you know the perfect place to plan your next date.